So this will begin chapter 14. We'll work with what we call rational expressions. Rational expressions is when we have an expression that has a numerator and a denominator in it. So remember, if the numerator and denominator have like factors, those factors can be divided out, or sometimes we use this phrase canceled. So if I want to simplify this rational expression, one of the ways of doing it is doing a factorization on it. A certain type of factorization that would be helpful here would be to do what we call a prime factorization. So if I do a prime factorization, our prime numbers are 2, 3, 5, 7, 11. Sometimes we use 13 a little bit, and they just keep on going. But most often we can use these prime numbers to help reduce things. So what I can do is I can use like a little T-chart as an organizer. And let's just start with the 539. Well, I know 2 is not a factor of 539 because 539 is an odd number and 2 only works for even numbers. So that's out. So 3, let's try the 3. So 539 divided by 3, and 3 doesn't work. So that's going to move us to the 5. Well, 5's not going to work because it doesn't end in a 0 or a 5. So let's try 7. So 539 divided by 7 is 77. So I can change 539 to 7 times 77. Now the question is 77 still factorable? It looks like 7 does go into 77 as well. So 77 divided by 7, notice how that would be an 11. So I kind of know my multiples of 11 there. So 7 is going to go into 77 11 times. And notice that 11 is a prime number. So the only thing that's going to go into 11 is itself. So 11 goes into 11 one time. So what I could do is change 539 to 7 times 7 times 11. So it has those factors in it. So the 847, hopefully we're thinking about the 7 again. So the 2 is not going to work. Let's see about the 3 just in case. 847 divided by 3, it doesn't work. We know 5 doesn't work because again, it has to end in a 0 and a 5. So we're back to the 7 again. So let's see if 7 goes into that as well. 847 divided by 7 is 121. So notice how 7 does go in 847 121 times. So then I recognize that 121 as well. Looks like that's where the 11 is going to come into play. So, because I know 7 is probably not going to work. 121 divided by 7, no. But I do feel like 121 is a perfect square. So if I divide that by an 11, it should give me an 11. So notice that 11 does go to 121 11 times, and then we do know that 11 goes into 11 one time. So again, the prime factorization, or the factorization, if you will, of 847 would be 7 times 11 times 11. So what I can do then is cancel out or divide out like factors. So let's say 7 divided by 7 is 1, and 11 divided by 11 is 1. So when you multiply by ones, they just kind of drop out. That's kind of what we call the multiplicative identity. It doesn't really change anything. So it looks like all we have left is a 7 over 11. So I can do what we call a factorization of it and then cancel out like factors. Now, since this is a number, you can just type this into the calculator a couple of ways. One way is you actually could just type in 539 divided by 847. And then you can go up to math and say, change it to a fraction. Notice how it reduces it down for me to 7/11. You also can put 539 over 847 into the calculator as a fraction. So there's a special menu up here, the F1, but notice how F1 is in green. So if I hit the alpha button, and then hit the Y equals button, it'll activate the F1 menu. Notice how number one is a fraction mode. So it kind of gives me a little pattern here to put a fraction in. So I could put the 539 in the numerator. I could then move the 847, move the directional pad there and put the 847 in the denominator and then hit enter and it'll give me 7/11. So I can reduce that using the calculator since it's a number, but one of the keys is actually what we call factoring and canceling out like factors.